Our product support, when I say that Ovivo, my team, what we do is when a plant is sold and installed, we literally go out there to do the startup, troubleshooting, and maintain the relationship with you guys. So I'm sure you probably know the team, at least some of the team here and there, but on this particular plant, we did an install of the membranes, and it was one of the most difficult plants that I've ever had to deal with to resolve. It is not very common even though the problems that we saw at this plant, the problems have occurred and we have solutions for the problem, but we really did not have so many layers of problems or root causes to the problem at this plant. So I just want everyone to know that, again, it was, I think, about a 2-year we spent from the installation of the membranes and then to about where we are now. It's been about 2 years, and we're finally getting to a point where we are heading in the right path. So, Bob, if you wouldn't mind starting off and tell us a little bit about your plant.
Yeah, it's actually a 0.66 MGD plant. It's been derated to a $500,000. It's in a resort community in Key Largo. Really, the season is November to Easter. Mosquitoes show up, everybody leaves after that, and then it gets real slow. About 10 years ago, we were told that we were going to go to a 5531 permit. It's 5 BOD, 5 TSS, 3 TN, and 1 TP. So we started an upgrade plans. 8 years ago, we upgraded our plant. We brought in, we went with Kubota membranes at that time, and it was 2 trains, and we had the Kubota membranes for about 5 years. Always had dewatering problems, but at that time, all the dewatering problems we could kind of figure out what they were. It was operator error. Unfortunately, I was the operator. Mechanical problems, bolts coming loose, and the diffuser's shaking off the air header. Like I said, but we always knew what caused the dewatering. About 5 years ago, Bill came in, started working for us, and we pulled 3,200 membranes and cleaned them. I told Bill it'd get a little better after, but it got slightly better, but it's been a struggle. We were pursuing thickening. We were going to do a membrane thickener. We were going to do it dedicated in the digester. Dennis came up with the idea of kind of dual purposing one of the trains. We ended up turning it into backing up about 300 days a year. Our flows are low enough that we can just run one train. We have our peaks around Christmas where we need to run a little bit more, and we need actually 2 trains to get through those high peaks. So Dennis came up with the idea of putting a digester / multi-purposing it. We could use it for thickening, and then when we needed it for those few days, we could actually bring it online and help with the additional flows. So we went with that, and it also enabled us to look at the microdyne technology, which I liked. It was it was a flat plate, but not the hard 3,200 plates that we removed with the Kubota. So we tried that, and we were hoping it would be less work, but it turned out we had a bunch of dewatering problems.
Yeah, would we say about every 2 weeks?
Yeah, it was a struggle, and I guess Eddie can kind of take over and kind of start talking about what we did. And
well, the first thing I think, if I remember correctly, is the first call I got. I was hoping it was like, hey, I love everything's running great, but it was really, man, my turbidity is high and my permeability is low. And I don't know if we really drained the tank to the day one when we started having that observation. But we did go out there and we did look at the plant, and we started with obviously whatever was above the water level. So we did look at the solenoid valve, the vent valve, and we checked that, and we did find that needed to be replaced. We replaced that. We also checked all the valves and the piping and the Victaulic flanges. We did the same thing we typically do as we go from component to component. And then we started to drain the tank, and obviously dewatered. And every time we went out there, we would identify another layer to that problem. Victolic connections, loose flanges. We even questioned whether the RAS rate was the problem. Were we not having enough feed forward or return to make sure that we didn't prevent thickening? Wasn't the problem. We went down the level of installing some mixed liquor probes because we thought maybe we had some preferential management of hydraulics. And again, every time we thought we had that problem solved, 2 weeks later, Bill would give me a call and make it clear that they were dewatered again, and we hadn't solved that problem. The good thing is we went through that root cause analysis of that strategy, and we were finding problems with the plant, and we were resolving those problems, and we were seeing some improvement, but it wasn't the end solution. This wasn't a simple fix a problem and move on. I think we probably touched every piece of equipment on that plant more than once. And we'll talk a little bit about the solenoid valves. We actually replaced those solenoid valves because we were bad, so we checked those off the list. I think, Bill, you remember the first time we changed those. I think we went up there with a dollar bill, and we could see that dollar bill was getting sucked tight against that pipe when the valve was supposed to be closed, so we knew it was leaking. We thought we solved that problem. And again, I guess we've been doing this for so long, I couldn't remember how long it had been. And Bob told me, this has been going on for 2 years now that we're finally getting to the point of solving the overall problem. But again, this is the turbidity issue was identified, and Bob and Bill both were able to link the two, turbidity with dewatering. So what we would notice that even after we would remove the dewatering, in a day or two or a week would go by, then they would start to see that turbidity start to creep up. And sure enough, I'd get a call from Bill and say, I'm pretty sure we're starting to dewater again. Drain the tank, we started dewatering again. So we kept drilling down to identify the problem at this facility. When we really drained the tank and we got down to the bottom, we found that the diffusers, the air scour diffusers below the membranes, were bad. They were full of sludge. And whenever you have sludge in your diffusers, your air scour, you actually interrupt the actual roll pattern. And it's very important that you have very equal air distribution amongst that unit. And if you do not have equal air distribution, you can cause damage to the units, dewatering, and obviously, of course, the diffusers themselves, but everything above them has the potential of falling apart, to be honest with you. So we went in and we replaced those diffusers, and I believe we pulled every unit out. We went from the air strip to the Norris.
Right, we had Norris in half, remember?
That's right. So we did one basin at a time, and the thought was once we replace these diffusers, we should see no more dewatering in basin number 2, or I think it was number 2 that we started with.
I think so.
And so we would have a comparison. Unfortunately, what we were seeing is even then, we were still getting dewatering in the basin that we had replaced the diffusers. So we knew that we weren't done yet. But at that point, we had literally put our hands on every piece of equipment. I mean, literally, we've turned over every rock. And at that point in time, we realized, or I realized personally, that this is going to go beyond just a day-to-day operation, and we had to really get back to engineering support, escalate the case, and get more people involved. And Mike Snodgrass and many others were there in Austin to support us during the troubleshooting of this effort.
So in case you haven't noticed from yesterday and today, we've been talking a lot about data. And we like data and how useful data is in the operation of a plant, troubleshooting a plant, making sure everything's performing well. What I think makes Ocean Reef both an interesting and compelling case study is that we had loads and loads of data, both in terms of online monitoring, but also all the data that Bob was providing, from measurements directly from the basin, observations, all that type of stuff.
We installed specific energy.
Yeah.
We did that. Yeah.
So what was troubling about Ocean Reef is, we looked at obviously the main culprits or the main suspects in terms of dewatering, and the data was actually telling us, hey, everything's okay. First, we looked at coarse suspended solids. Initially, it was a little bit on the higher side, nothing major, but nonetheless, we thought, hey, maybe it's a good idea to rescreen the basins. They did that. CSS dropped way down. but we still saw the dewatering. So, we felt, pretty confident that CSS was not the issue. Of course, the next factor we look at is, well, okay, what's the mixed liquor concentration? What's the profile of the solids in the basin? Despite one of the basins having some variability to it, as you can see, it was sort of the up and down pattern, which we figured out was probably due to the actual location of the
Right.
sensor. But nonetheless, there was nothing alarming about these numbers. They were definitely within the limits. There weren't any major excursions, so once again, we're scratching our heads. And we looked at everything. We looked at air scour, we looked at the relax frequency. I mean, we literally looked at every single data point we possibly could. And everything was telling us, it's okay. You're within your limits. You're within your operating guidelines. So we're certainly scratching our heads trying to figure out what was going on and what was causing the dewatering. Now, data means a lot of things. Obviously, it's numbers, it's charts, it's plots, but really, data is information. And we started looking at different parts of the system, not necessarily all the operating data. And one day, I think we had a conference call with Microdyne, and we were just talking about, just trying to figure out, okay, what is different about this plant? And somebody made the comment, well, the side water depth, that seems a little unusually high compared to what other plants are. And that was sort of our eureka moment. The light bulb went off, and then we started going down the path of looking at, okay, is the side water depth an issue here? And is that compounding the problem? So then we did a profile of all of our operating plants looking at the side water depth. And lo and behold, there were 2 plants, as you see circled by the red dots, that had an unusually high submergence levels. So, those 2 plants also have dewatering issues. So maybe there's a common thread there. So now we're feeling pretty confident that we are moving down the right path. We started crunching some numbers. We started looking at the side water depth, the submergence. We started looking at ACFM compared to SCFM. And then we discovered, well, hey, our ACFM, that's actually a low number. Even though our SCFM was certainly within the limits, it was at its design value. We never had issues with the air scour. But then once we looked at it from a different angle, then we realized, hey, maybe our ACFM is too low. And then that's when we started down the path of our solution, which was adjusting the side water depth and the submergence of the system.
And just so you can see, even though you see these 2 lines here, if you see the numbers below, those are actually a total of 22 plants that was, when I'm in a tank and I'm looking at what could possibly be this problem, we're talking with engineering, we're talking with Mike, and we say, maybe this thing is too deep in the water. It's about 6 feet below the water. Now, I'm not just going to put my thumb in the air and we're going to just lift these things up and spend $50,000 and find out that's not the solution. So data, like Mike said, it's data. He's the one that was able to come back and say, okay, let's look into that. Let's take data from 22 different plants, and let's be able to compare the 2. And so you're seeing that red line. Not only did he look at the depth of the water from the top of the membranes, he also looked from the top of the water down to the center point of the diffusers. And you will see the blue line between the 2 red circles at the top. You see that one's high. You probably wonder, well, why wasn't that one a problem? It just so happens that particular plant was running springs. I think Trevor has already probably gone back home. That plant, that has the same type of membranes, but they're double stacked, right? So really, that water level is 20 feet deep, but with 2 units stacked on top of each other, there's only about 2 feet of water above the membranes, right? So it's almost like, think about an airlift pump, right? So that's the reason why that one doesn't have a red line on it, because there wasn't really that much water over those units. It was only Marathon and Ocean Reef that we'd experienced 5 to 6 feet over the membranes. So we did install the platform. I'm pretty sure you remember those days.
Yeah, and part of the problem was the plant was designed for the double stack unit. So now we had a problem with our maintaining that level. We tried just running it without any instrumentation help, and
Right.
and they were going up and down, and we had no control, and we actually controlled our feed forwards and our RAS pumps to be able to maintain that depth, and that's worked well since we did that.
Right, so the double stack Kubota membranes that were in there, they actually, when we removed those and put the single stack OVs that were able to meet capacity, like you said, that they were lower in the water, Oh, sorry about that. I almost hiccup. So they were lower in the water, and so what we did is we did change the program, and that became almost impossible to actually maintain the level even with the program itself. So where we thought we were maintaining 1.5 or 2 feet, one day would go by, and an hour or two later, the level would be back up 4 or 5 feet above them, and it didn't take long. If the water was above that threshold, that acceptable level above the membranes, I wouldn't say that it was instantaneous, but it dang sure didn't take a week. It was already starting to dewater. So the next step was, how do we get the membranes higher, right? So we thought, okay, well let's just lift them up. What a great idea! What a concept, right? So if we would have just lifted the units up and left the diffusers below, we would have created another problem, because there's a lot of engineering behind the idea of how close those diffusers are to the bottom of the unit. So what we were able to do is almost lift the unit up and put a skirt on the bottom of the diffuser case, so that just as important as it is to make sure you maintain the proper water level above the membranes, it's important that you maintain the proper opening below the unit as well, right? You can go, if you go too low, I assume the velocity can be increased and some other issues. Obviously, I'm not in the engineering, but it does create a problem. So we probably took about 2 weeks to develop the product and put it in. I think it probably 2 to 3 days to actually rip them out and put them back in the basin.
Yeah, I think we did. I think we could do a basin 2 days, I think it was.
So the submergence was definitely an issue, but guess what? It didn't solve the problem. We were still getting dewatering, right? So you can imagine when I'd get on the phone and talk to Bill and Bob, and my concern was more of whether or not they were going to let me back in that door, more than it was anything else. But obviously they're very supportive and very, they were hands-on in the whole process. So did we quit? No, we went right back out there. So we started off with 100 SCFM, and we were 6 feet deep. That's how much water was pretty much above the top of the membranes, right? We had the ASCO valve, we replaced it, but they were still dewatering, right? Every 2 weeks. So we thought maybe the air, we dropped the airflow. Again, the unit was still 6 feet under the water. Didn't fix the problem. So we said, let's leave the airflow down, let's add the platforms, let's lift the units, and guess what? We were still dewatering. We were able to also identify something that we found here first at this facility. Those ASCO valves, I don't know if you guys have ever seen those solenoid valves, are usually almost gold in color. And they're a diaphragm valve that is usually what we used in the past to allow to be open during relax, to relieve any air out of the system, and then closed during permeate. Well, in normal operations for the last 10 years, we've operated from about a 0 to 3 TMP. And if anybody's ever seen the map that's probably hanging on your wall, it probably says something in the ranges of, if you see an increase in that TMP of a 1 to a 1.5 PSI, you need to do a clean. So that means that we have been operating our facilities, most of us have been operating less than about 2 PSI, right? So we do a clean, you're probably 0.3, maybe to 0.5. As the days and weeks, hopefully months go by, you increase the TMP, and as you see it get up to 2, you would do a clean. Well, the particular membranes that were installed, they had a range of operation between 0 and 5.8. So we were allowed to let the membranes operate at a higher TMP value. Well, that solenoid valve wasn't designed to handle anything higher than about a 2.5 loss of pressure. And once you get up to that 2.5, it will actually, even though it's a brand new valve, it'll crack open and let air into the system. And I think when we get over to the technology center, you're gonna have an opportunity to see that pilot that we actually put a 1/16 pinhole on a valve so we can open that and you can see exactly how much air do you get. Well, on a ASCO valve, it has a 7/16 hole. So what you're about to see at the technology center is probably 1/20th or 100th of size compared to what that valve was doing, the problem it was causing. So, and Bill, we sent him some Asahi ball valves, the same ball valve that we use throughout the plant, on the same valve that we use on the vents for the CIP, but we did put an actuator on top of it. And so we did kick the airflow back up to 85. The membranes are now raised with the platform with 2 feet of water, approximately 2 feet of water above them. And with that solenoid valve replaced with a new ball valve, things got better. So it would be great to say that there's always only one single root cause to the problem, but it's clear that there are some times when we get into a situation where there's just layer after layer after layer. So the good thing is when you accomplish that, and you, even though we've been operating, how long have we been operating, Bill, since we changed those solenoid valves? So that's been a few months. I mean, obviously, we've been dealing with this problem for 2 years, so we're a little skittish. Time will only tell. But to know that we've made it this long, I know we're good. I know we're heading in the right spot, and we still drain and inspect the tanks. Bill, would you say that things are a lot better? That's good to hear. Now I'll probably give you a call and ask how things are going, so I'm not so nervous about that call. But here's an example of that solenoid valve. If you look at the left side of the red line, that value is permeability, and it's all over the place, high and low during every cycle throughout the day. And that about the time frame of when Bill was able to replace that solenoid valve with the actuated valve and stop that leak, you can see how that line, even it's going down, which is pretty normal between cleans. What you're seeing is a pretty much normal operation, but it's steady. It's not all over the place. It's very trackable. So it was something actually that now, when we put it in the CRM, we put it in the Water Expert, whenever this problem shows up at another facility, one of the first things they're going to pop up is, hey, do you still have that ASCO solenoid valve in there? Does it need to be replaced, right? So we've already started retrofitting a lot of our facilities, but this kind of data, this kind of, the events that we have, I mean, they were cumbersome, they took a long time, but all that information is just not lost over at Ocean Reef. It's going to be applied into the actual CRM, into the Water Expert, so it's available to everybody. So.
Just real quick, Eddie, just to, after we raised the units with the platforms, got the ACFM levels higher where they should be, obviously we saw a drastic improvement in performance. Permeabilities were much higher. They were more stable. We didn't see, go back to that slide.
Sorry.
They were significantly better than what we had seen previously. So, a lot of us, we thought the job was done. We could go home, call it a day, and being the data geek that Dennis is, he wasn't happy with the fact that the permeability numbers were so variable. And, it's a good thing he harped on that, because it led us down the path of finding the air leaks, because that was, in fact, that was causing the variability in the permeability. So as you can see from this data, once those valves were installed, now you get nice tighter lines with the permeability. And now the permeability numbers are even higher than what they were previously. So now we have a true indication of the performance of the membranes. So all in all, it's now we're getting a clear idea of how well the membranes are running and how much we've improved the situation through everybody's work.
Another issue with the solenoid was that on the high flows is when it really leaked. It didn't have the suction at low and medium flow rates, so we didn't see it that often. So we could have been fine for 85% of the time, and then we went to high flows, and that's could have been when we were dewatering. We're not quite sure because we weren't looking at it every day and stuff. So that was also another variable in the whole issue.
So, if I remember correctly, you guys were pretty much cleaning every 2 weeks with bleach?
Yeah, I'm looking at two guys. These two guys are in the tank. Frank was in the tank. We had a lot of different people in the
Matthew?
tank doing. Yep.
Actually, I'd like just to raise a hands of who has been involved at the Ocean Reef and who's been in the tank. Obviously, Bill, you have there. We have Matthew. We have a few people. I think some of them aren't even here. They're probably over at the tech center. I'd say we've had at least a dozen. But how often are you cleaning now?
We've cleaned a prescribed clean that I think Mike set up for a monthly with some flow testing afterwards. But it's kind of funny when Dennis showed all the pictures of everybody, all the employees. I recognize about half of them, and it's not good. It's not good when you recognize that many people. Eddie's a nice guy, but if you see him at your plant more than a couple times, it's not a good sign or whatever. So, But yeah, we definitely had a lot of all hands on deck situations on this job.
But again, I'd like to personally thank Bill again because he really jumped in and he jumped in that tank literally and helped us remove the dewatering and move in and brainstormed with us. And a lot of our success was with his input as well. And we're going to make sure that input's not lost. All of that information, again, goes into that CRM and goes into that water expert. So everyone has the ability to see the probability of when we have a problem, what's the probability, what's the solution, what's the right way to go, instead of just, putting your thumb in the air and just guessing. So here we are making success. I get it on the phone. I say, hey, Bob, engineering's got this great idea. I think Anya here was the one that came up with the first one that came up with this. It says, you guys have already taken the sides off of these membranes once or twice just to remove the dewatering. Do you mind if we just leave them off for testing purposes?
So I got this vision in my head that a week later we drain it and they're all twisted and everything from the forces or whatever. Fortunately, that didn't work out. Everything went well, and they've been off for a month now?
Bill, about a month?
2 months.
Oh,
yeah.
wow.
One thing we notice is when we drain it, we're also aerating, and I think Bill's seen some sludge actually fall out of the sides a little bit. And Frank, when he went in, he said that this was the best looking. He'd been numerous times, and that was the best looking that they've looked. They were pretty much free of any dewatering at all. So we're getting there, or hopefully we are there.
So, I mean, even though we did a lot at that plant, and in the end, through all our troubleshooting, pretty much all the equipment is new. That's good, right? But in the end, when it really comes down to the problem, it was without declining permeability, frequent cleanings because of frequent dewatering, and it was a lot of manual labor, right? And then all the data that was gone through is, even though we show mixed liquor, CSS, CIP, water quality, submergence, there was a lot of other things we looked at as well. Health of biology, RAS rates. We looked at the entire system, and without that data, honestly, we wouldn't have been able to get to this point that we are at now, where we're actually thumbs up and everyone is feeling a little better about the operation of that plant. And again, the root cause, submergence. We cannot put those things 6 feet below the water level. I mean, we all know what typically you put 6 feet below the water, 6 feet below the ground, right? I mean, that's just where problems happen. I think, what is the actual range that's acceptable, Mike?
What was it?
How much is the submergence? What's an allowable submergence?
What is it, about 0.6 meters?
Yeah, about 0.6. We're looking at about 2.5 feet. I think we have some data that shows that we can go about 3 feet deep, but typically we're shooting for that 0.6 meters. And all that information is just not left here. Again, it's going back to the front end to make sure all the plants moving forward, we don't commit to retrofitting by just dropping membranes in there, right? So if we pay close attention to how deep those units are in the water. So again, we raise the units, we kick the airflow to 85 SCFM, and we replace the vent valve. Now, if we would have had CRM, we would have had that water expert, we would have probably identified those 3, maybe 4 or 5 issues early on, and we probably would have been able to be in a better solution 3, 4, maybe 5 months instead of 2 years. But again, with all the support from Ocean Reef, from Bob, from Bill, and Mark, we were able to solve that problem. Again, thank you.
Okay. Sorry, carry on.
No, you're good.
Yeah. I think you've probably done the takeaways.
Yeah, that was the
last
takeaway.
little précis there. Okay, well, thank you very much. Cheers.
Any questions?
Okay, we've got time for 5 minutes of questions. Yes, sir. So the question was, how long was the startup before you started experiencing problems? I'll try and remember to recite the question so everyone can hear them in
It was
future.
pretty much immediately. And one thing that kind of surprised us is turbidity ended up being the indicator that it wasn't so much our TMP or our numbers, it was turbidity is what kind of started alarming us, that we realized there was a correlation between when we have a point, I didn't mention we have a 0.2 NTU turbidity. We're running UV, so we have a tight turbidity. 90% of the time it's got to be 0.2. So that really became the indicator for us. And sure enough, the turbidity would go up and we'd start seeing it, but it was almost immediately, you know. And we have varying flows, you know, it's, like I said, it's a seasonal community, so it was kind of up and down on the flows a lot too.
Any other questions?
Were you experiencing the problem on the thickener side as well?
No, the thickener was used just a little bit. You know, and as a thickener, our flux rates were so low, we weren't seeing that. We looked at that thinking maybe it was an overall problem, but it was pretty much the submergence.
So before that thickener was converted to a thickener, it was an MBR with double stacks, and I'm pretty sure that you did see dewatering in that.
Originally, when it was
Right.
just being used, yeah, that's always been an issue. Like I said, that was always something we could actually trace back to mechanical high mixed liquors.
Air entrainment was one of probably the main contributors to the root cause on that. I think that's when we drained the tank and we redid some piping. We added a vent valve to allow that air to be released during relax.
Right, they were both in with the Kubotas, yeah.
Right. So.
So is the permeate always pumped, or is it presumably gravity? Yeah.
No, it's
gravity.
always pumped.
Okay, right. Any other question? No, I had one last one actually about the removing of the sides of the module, which I think, did you say the suppliers, the technology
Anya,
suppliers?
I think Anya was the first one that brought that up, actually.
Is there any, I mean, I can see the logic of it really. You kind of think, well, why doesn't everybody do that? But is there a particular reason why you thought of that? Or? So why remove? Yeah, essentially the idea of just removing the sides of the modules. On the face of it, it seems like an obvious thing to do, but what sort of triggered that particular thought?
It was a reason to flush some air go somewhere.
Oh, okay. So it's just displacing the sludge from the channels.
Yeah, but we were afraid that the air might not go away.
Yeah.
That was the reason why we said we have to try this first before we some of you will be an iPad interviews, you can see something coming, so before you discuss it.
Okay. Interesting stuff.
Yeah, I think lots of times we'd see sludge accumulation on the sides
Yeah,
of the module.
exactly.
So
Yeah.
that
So if you
was-
push it out the sides, then
Right.
you got no fluid drag there. So it kind of makes sense thinking about it. Thank you very much indeed, gentlemen.
All right.